Alright guys, here I am going to go over the latest review sheet 20, and show you the answers to this version of it, and just go over again, clarify some stuff as we get ready for the Common Core exam. So the first example says, given triangle ADC and triangle EBC shown in the diagram below with segment BC congruent to segment DC. Which statement is needed to prove triangle ADC is congruent to triangle EBC? So the first thing I'm going to do is ADC congruent to triangle EBC. I'm going to make my list of 6. So segment AD, segment EB, segment DC, segment BC, and segment AC is congruent to segment EC. I'm going to do my angles. Angle ADC is congruent to angle EBC, angle DCA congruent to angle BCE, and angle CAD is congruent to angle CEB. Alright, so they've already listed some angles here. So they've got this is angle 1, they've got this is angle 2, this is angle 3, which is congruent to itself. That's reflexive. So I already have an angle, and they gave us BC and DC, so I have a side already. Alright, and you could go ahead and list ADC as angle 4, and angle EBC as angle 5, just like we did. So I've listed all my segments based on congruent triangles. Now, if I'm going for side, angle, side, that means the angle has to be between two sides. I already have a side and an angle. I'm not going for another angle then. So I'm going to go ahead and cross off choice 1 and 2. I'm not looking for an angle at this point. So now what I have to do is I have to take a look at these triangles. So I'm looking at triangle ADC. I'm going to look at one at a time. I'm going to go through my list of sides and see what is going to make this side, angle, side. What I'm also going to do to show you is I'm going to pull this triangle out. This is angle C, this is angle D, this is angle A. And I already have side CD, and I already have this angle here. The only other side, that would possibly make this side angle side is if I had side AC. And that's not a choice here. Okay, AC is not a choice here. So I've got to look at how can I make this side AC happen? Well, my choices are AD and EB being congruent. AD would not make it side angle side. So I got to get rid of that choice. This would not make it side angle side. But if AB was congruent to ED, then I can use segment addition and I can get the full side of AC. So it might not be a side, but it says which statement is needed to prove. It didn't say which additional side or angle. But you have to make your list. You have to mark up your diagram in order to see what's going on here. Alright? Now this next one, in triangle ABC and triangle DEF, these segments, these are segments. These are sides in proportion. That's what that is. When a fraction equals a fraction, those are sides. They're corresponding sides that are in proportion. It says what additional information would prove the two triangles similar. Now, there's angle-angle similarity, there's side-side-side similarity, and there's side-angle-side similarity. They've given me two sides. There's no way I'm going for angles. I'm not going for an angle here. Okay? It's sides, and I'm looking for either another set of sides to be in proportion, or I'm looking for an angle to be between these two sides. Now, sides of similar triangles are not congruent for the 5 millionth time. The sides are not congruent in similar triangles. They are in proportion. They are not the same size. They are in proportion. They were created by dilations. So I'm just going to actually set up triangle ABC and triangle DEF. Now, the sides are not congruent, so I'm not going to mark them congruent, but what I'm going to do is I'm going to mark them that they're in proportion. So AC is in proportion and corresponds with DF. Not congruent, so I'm not putting little hash marks in them. And then we have side CB, which is this guy here, and side FE being in proportion. So I've got two sides. I'm not going to get a third side to be in proportion because they didn't give me any choices, so that's gone. So it looks like I'm looking for side, angle, side. Again, I'm looking for the angle to be in between the two sides. It's the two sides of the angle that I'm looking for. Well, where do these two sides meet? These two sides meet at angle C and at angle F. So it must be where I have vertex C equaling vertex F. So ABC, nope, C and F are not in the middle. ACB, DFE. This guy looks like it's it. BAC, nope, that's angle A. And EDF, nope, that's angle D. Now another way that you can tell what angle you're looking for, this letter C repeats. This letter F repeats. Weird. The letter that's repeating is the letter that's in both of those sides, which means it's the angle that's between those two sides. Okay, so again, side, angle, side, similarity versus side, angle, side, congruent. Two totally different problems there. All right, this guy here. We have the accompanying diagram shows the parts of architectural plans for a structural support of a building. Plan is a rectangle, so right off the bat, I know that I have 4 right angles. And it says which equation can be used to find AS. All right, so here's what I'm looking for. I'm looking for AS. I'm looking for this guy right here. And I look at this problem and I recognize that this is an altitude problem. If I take a look at this triangle here, this is a right triangle. And if I have this AS being perpendicular, drawn perpendicular to that, that means I have a right angle here and I have 2 right angles here, which leads me to understand that I've got some similar triangles, and I'm either working with a PAP problem or I'm working with PSH. Now, it involves the altitude. It specifically wants the altitude. So I know I'm going for PAP here. And I know my altitude is AS, so I substitute it right in. Now, I know that the P's are the parts of the hypotenuse. So this is a part of the hypotenuse, and this is a part of the hypotenuse. So I'm going to say LS is in a ratio with AS, which is in a ratio to SN. Again, these are ratios. In order to get our scale factors, we do right over left and right over left. So, scale factors are right over left. These are scale factors. Scale factors are representations of the sides being in proportion. So, I'm gonna look and see which one has got the same thing going on here. This guy doesn't have 2 AS's, which it has to because it's the geometric mean. This side doesn't have 2 AS's. These two do. But if you look again, my AS is my mean proportion, meaning I'm going to be multiplying it. And then LS and SN. So this guy doesn't make any sense. This guy looks to be the only one that makes sense there. So I first have to recognize that I have perpendicular lines and I have right angles. And I have a rectangle. All of these give me the right angles I need to have similar triangles to be able to set up our PAP and PSH proportions. Alright? Now, this guy should be going right into the Inspire. You should be putting this right into the Inspire, but I know that some of you either, do it on your own, you don't have the Inspire, so this is where we have to complete the square. So we're going to gather our X terms, we're going to gather our Y terms, and we're going to get our constant on the other side. Now, I don't have any X terms to divide by 2 to complete the square, so that remains as X squared. This becomes Y squared. I take the negative 16, I divide it by 2, and I square it, which gives me 64. So this becomes y squared minus 16y plus 64. And to balance this equation, it's negative 14 plus 64. Okay? Now, that's 64 minus 14, which leaves me with 50. This guy stays as x squared. There's nothing to factor there. This gets broken down. Again, couple ways you can do this. I take the square root, and I take the sine of this middle term. So I'm going to have y minus 8 squared. From there, I know my center is going to be 0, 8, so I'm getting rid of this choice, I'm getting rid of this choice, and I know that r squared equals 50. This is r squared. A squared plus b squared equals c squared. So r is the square root of 50. And I can either break that down, or I can understand that it's not the square root of 14, so 5 radical 2, if I plug it in my calculator, has the same value as the square root of 50. Alright, partitioning a segment. So I have given this segment AB, which means I have to go in order, the direction A to B. So I'm going to start with A. I think we did really well with this question. And I need 1, 2, 3 segments. I partition it off, and there's B. So I have negative 3, negative 3. Make sure you write all your numbers correctly. 5, 1. And I have 3 parts to 1 part. 3 to 1 ratio for 4 total parts. Okay? Now again, this is our strong and our weak. My partition here is closer to B. So that gets my strong ratio. This is my weaker side. It gets my weak ratio. So this guy's strong. This guy's weak. It's where the pull is closer to. Tug of war. Alright? This gives me 15, 3. This gives me negative 3, negative 3. This is x. This is y. This is x. This is y. Now I have to take the average of these weighted points. Think about your grades. You don't take your average of chemistry and your average of geometry. You take all of your geometry scores. So I'm going to take my average of x, and I'm going to take my average of y. Again, when you average, you add the numbers and you divide by the total. When you average your y's, you add the y's and you divide by your total. Well, 15 minus 3 is 12. 12 divided by 4 is 3. Negative 3 plus 3 is 0. 0 divided by 4 is 0. If you were to graph this, you would see that you would have point A and you would have point B, and this point P would be closer to B, and it would be on the line. If it's not on the line, then you didn't find the right partition point. Alright? This last guy here. So, I have AB is 12, segment AB is 12, segment DC is 17 feet, the measure of angle ABD is 40, and the measure of angle ABD is 40, and ADB is 110. So already that's 150. That leaves me with 30 here. I also know that this guy is 70. Another triangle. This guy is 20. And I want to find AC to the nearest foot. So if I look at the triangle that AC is actually in, it's a right triangle. But I don't have any of the sides and I don't have any of the angles. So I've got to focus on some other sides and some other angles. So again, it does help when you take and you redraw some triangles. So this guy here, I have a right triangle. Right here. So I'm going to pull that guy out. That's 12. This whole angle is 50. And I can find this value here. Now again, this is my adjacent, this is my opposite the 50, and this is my hypotenuse. So opposite and hypotenuse, I'm going to use the tangent of 50 equals x over the hypotenuse, which is 12. Okay, and I'm going to find